2709, and greatest common divisor traversal. So for this problem, we are given a zero index array nums, and you are allowed to traverse between its indices. So for example, we can traverse between index I and index j if they are not equal. So for example, 2 and 3. So if and only if GCD of those two numbers, so for example 2 and 3 is more than 1, and then we're gonna, GCD is just the greatest common divisor. If it is more than 1, and then we'll consider I and j should be those two numbers should be connected. So for 2 and 3, the GCD is 1, so 2 and 3 is not connected. So what about 2 and 6? So for 2 and 6, it is connected. So 2 and 6, it is connected. So what about 3 and 6? 3 and 6 is connected because the GCD of 3 and 6 is 3, GCD of 2 and 6 is 2, it is more than 1. So it means 2 and 3 should be connected as well, because 2 connected to 6 connected to 3, it means 2 and 3 should be connected. So this is why we're gonna return true if it is possible to traverse all such pairs of indices or false otherwise. So this means we can traverse 2, 3, and 6, so it's gonna be a true. If you are thinking about the problem, if two nodes are connected like 2 and 6, 3 and 6, 2 and 6, so 2 and 3 are going to be connected. So what kind of algorithm we're going to use? Of course, it is the unified, so we're going to call it UF. So another thing is how can we find the GCD? I mean the greatest common divisor. Yeah. So for example, for number 6. Do we need to check like 2, 6, 3, 6? Do we need to check all of them? Yeah, because in this algorithm, actually, we use the n square to connect all the different cases. Yeah, as you can see, the length of the n is only 10 to the power 5. This means we cannot use the brute force directly to solve the problem. But we're gonna check each numbers. We're gonna find all its divisors. So for number 2. What about its divisors? It is 1 and 2. So what about 3? It is 1 and 3. So what about number 6? 1 and 3 here. So it is 1, 2, 3, and 6. Yeah. So we're gonna check all the so we're gonna find all the prime factors. So we will ignore this one, and ignore the 1. So let me just remove it. So we will ignore 1. We're gonna check all the prime factors. So for 2, we have prime factors of 2, and 3 we have 3, and what about 6? We have 2, 3, and 6. Yeah. So this means for this number 6, we just need to connect all the prime factors. So that is okay. So for 6, we have 2, 3, and 6. Yeah. So this means we're gonna let me think about this 6. Yeah, so this means we will ignore this 6 because 6 is not a prime factor. Yeah, let me think about it. So for this 6, we will still think we're gonna have 6. 2. So for 6, we have the prime factors 2, 3, and we have the factors. We're gonna check all the possible factors. We have the factors 2, 3, and 6. So we're gonna connect 2, 3, and 6 together. And even for 2 and 3, it is a small number, but we have 2 and 3. So this means all those numbers are gonna be connected. Yeah. So what about 9? We still have the factor of 3. Yeah. So this means 9 and 6 should also be connected. And 9 and 2, 3, all those numbers are gonna be connected. Yeah, so let's just start coding, I think. So we're gonna use the unified. Let me just write the unified. I'm gonna define self.parent. It's gonna be list of rings with a, and then I'm gonna define the find. So while n not equal to self.parent n, so n gonna equal to self.parent n, and we're gonna return yeah, and the union. It's going to be self with n1 and n2. Let's first find its parents, p1 and p2. So it's going to be self dot find. Let's find n1, and let's just find n2. So self dot parent with p2 gonna be p1. So p2's parent is p1, and let me just define is connected. So self dot n1 and n2. So we're gonna return self dot find n1 gonna equal to self dot find with n2. Yeah. Now let's just do some other preparations. So this is just union find, and we also need to find all the divisors. So for example, for this number 6, we need to find the divisors. It's gonna be it's gonna be something like 2, 3, and 6. So let me call it factors maybe. It's gonna be a default dict, and it's gonna be list. And let's define e prime factors, because it's going to be the Aristotle's algorithm, similarly for finding prime numbers. But here we are just use it for finding prime factors. Yeah. So I'm going to call it e prime factors, and it's going to be a number of n. So the primes, I'm going to call it false times 2 plus true times n minus 1, and for I in range, we're gonna start from 2 to n plus 1. If primes I, so for j in range I to n plus 1, and the step gonna be I. So primes j gonna equal to false, and yeah, here we need to use the factors. The factors j gonna append I. Yeah. So for example, the factors yeah, let's say the factors 6. So if j equal to 6, this means definitely 6 is gonna append the 6, but the 6 is gonna append 2, and the 6 is gonna append 3, and 6 is gonna append 6. Yeah. So if you don't believe it, let's just check what is the factors, right? So we're gonna call e prime factors. We're gonna call it, and what's gonna be this number? It's gonna be 10 to the power 5. Okay. So we're gonna use 10 to the power 5. It's gonna be this number. So it's gonna be the maximum number. So after call it, let's just check what is factors. Maybe 6. Let's just check what is inside. Yeah, let me just give a random return. I think we need a return, maybe true or false. Let's just give a true. Yeah, let's check what is inside. For the first example, because this is running outside of the class, it means it is just running one time in case 1. So from here we can find it. It is 2 and 3. Yeah, so this means for 6 we have the prime factors 2 and 3, and we need to connect 2 and 3 together. So what about factors 3? Yeah, we only have 3. Yeah, I'm not sure, but let's just continue. I think for I needed to append the number itself. So for example, like factors 6, I needed to have 2, 3, and 6, but in my yeah, let me think about it. Yeah, I don't know. Maybe there's something wrong, but I don't know. Let's just check. So for this one, for 3, I have 3. So what about 6? Yeah, if I have 6, I need to have something like 2, 3, and 6. Yeah, but let's just wait for a moment. Let's just let me start coding. Maybe we can find the solution. Yeah, to how to add a number 6 inside, because for 6 basically we need to have like something like 2, 3, and 6. Actually, we need to find all the factors instead of prime factors. I think it is not prime factors, maybe. Yeah, but let's just start coding. So we're gonna call the unified, and it's gonna be the maximum of the nums. It's gonna be maximum of number plus a 1. So this is the definition for the unified. Basically, we need to find the maximum number. It's gonna plus a 1. And then we're going to check all the possible numbers. So for n inside, here we use the factors. So for n inside nums, so for AB in pair wise, with the factors of this number n. Yeah, if we find it, if we find the two factors, we need to check the greatest common divisor. So if GCD of A and B, yeah, let me think about it. I think the factors are gonna always be what's gonna be the number. The number gonna be more than and equal to 1. Yeah, this means if there's a number 1, definitely it is not possible. Yeah, so from here I will not check it. Yeah, because if I find a number 1, definitely it is not possible. So I will think all the numbers are going to be more than 1. It's going to be more than equal to 2. Yeah, so if it is like that, so definitely I need to definitely I need to connect them together. So for 6, so for example, for this number 6, I have the prime factors 2 and 3, but actually 2 and 6 gonna be connected. 6 and 3 gonna be connected because 2 is only a prime factor of 6, and 3 is also a prime factor of 6. If I can find all those prime factors, definitely it works. So for example, this 6, this is 9. So 3 is a prime factor of 9. This means 3 and 9 are gonna be connected, and 3 and 6 are gonna be connected. So this means 6 and 9 are going to be connected. Actually, the GCD of 6 and 9 is going to be 3. This is why it works. It's going to be more than 1. Yeah, and I think now it should be clear enough for us to understand the problem. Yeah, because for 6 we only need to have 2 and 3. So I think this is okay. Yeah, so let's just continue the coding. So if it is pairwise, what are we going to do? We're going to union them together. Yeah, we're going to union all of them together. Now let's just prepare a counter, because I just wanted to check how many numbers are connected. So for example, in this example, there are going to be 3 numbers are connected, so it's going to be a true. For this example, 3 and 9 are connected, but 5 and 3 is not connected, so this is why it is a false. Yeah. So I prepare a counter, and what I'm going to do? I think I just need to check all those numbers one by one. So here I just connected all the prime factors, and I think it should be okay. Okay. Now I just need to check all those. Yeah, I just need to check all those numbers to check if all those numbers are connected. So for example, 2, 3, and 6. So for n inside the nums. So if n equal to 1, definitely it's going to be a false. So where will I check this number 1? So I'm going to check it from here or from other places. So maybe inside of the nums there's a 1. So if n equals to 1, definitely it's going to be a false. So I'm going to check it from here. I think this is more easy. Otherwise, what I'm going to do? I'm gonna find a num. This num gonna be uf.find. Yeah, because I'm gonna use the union find to find its parent. So for this number, so num gonna be the parent, right? Maybe I'm gonna use the p. So p gonna equal to uf.find n. It's gonna be the parent, and dp gonna plus equal to 1. And I just wanted to check if all those numbers are connected. So yeah, this means if number, so for example, 2, 3, and 6. Yeah. So this means for this number 2, I want to find its parent, it's going to be itself. And for 3, I want to find its parent, it's going to be 2. And for 6, I want to find its parent, it's going to be 2. So this means for this node 2, I'm going to have a value of 3. So if it is equal to the length of the nums, basically it means it is true. Otherwise, it's going to be false. It means it is connected. So if dp, its parent, equal to length of the nums, so I'm going to return a true. Otherwise, I'm going to return a false. I think it's a lot of coding. Let's just check if it works. Let me just remove here and run it. Yeah, as you can see, it works. Now let me just submit it. Oh, it didn't work for this case. Yeah, I passed. There's only one testing case it didn't work. If the nums equals to 1, if I have a 1, it didn't work. I think from here I return false if n inside of the nums. If n equals to 1, oh, it should be a true. If n equals to 1, it is a true. Why it is a true? If the length of the nums is only 1, yeah, so this is I think it is only a special case we have to check. If the length of the nums equal to 1. Yeah, otherwise I think everybody gonna make mistakes. If there's only one node, so we're gonna think it will be connected. Even it is not mentioned, I think. Yeah, we're gonna check all of them are connected or not. But if there's only one node, it's gonna be true itself. So it means from here, we have to have another check. Oh, this is difficult. We have to make a mistake. If length of the nums equal to 1, so we're gonna return a false. I don't think if there's any other coding to avoid this, but definitely this is really difficult to avoid. Yeah, we have to no. But this time it's gonna be true. Yes, of course. It is not mentioned, right? Yeah, so for GCD with 1, and nums 0 equal to 1, it's going to be a false. Yeah, let me just run it and submit it to check. Maybe it works, maybe not. It's going to be a true. I don't know. Let me just use this testing case and run it and submit it. Yeah, now it works. Yeah, this is just some mistakes. So if there's a number, it is a 1. Definitely it didn't work. It is not described, I think, but inside of the testing case there is this one. I think it's really difficult to avoid such testing case. Yeah, if it is only one number, what's gonna happen? It is not mentioned. I think it is not mentioned if there's only one number. So if it is equal to 1, it's gonna be a true. Yeah, I still don't understand why we're gonna write it like this. Yeah, because for one number it is not mentioned. Yeah, but definitely this number can equal to 1. Yeah, because according to the definition, we need to at least check 2 numbers, I and j. If it meets the conditions, it's going to be connected. But what about only one number? So it is not mentioned. Yeah, so if it is possible to traverse between all such pairs of indices, it means we need to at least find 2 indices. But there are going to be testing cases of only 1 indices. So this is really strange, because according to the description, it's going to be at least 2 indices. The length of nums is going to be at least 2, but actually the nums can be 1. Yeah, but you know, if I set the length of the nums equal to 1, it didn't work. I think the length of the nums equal to 1, it should work. Oh, it works. Yeah, I don't know. I still don't understand. I think, yeah, as you can see, it works. So if the length of the nums equal to 1, so definitely it's gonna be true, because there's only one node. So it's gonna connect. Yeah, it's gonna. Yeah, so this is just a very strange. We have to use this case, even though it is not mentioned. But if the length of the nums is 1, definitely it's gonna be true. I don't know. Maybe if I test it, I don't know. Yeah, but it is like this, I think. That's enough for us to solve the problem. Yeah. Thanks for watching. See you next time.